So your page 1 should look like this. The pages are numbered. So look in the bottom corner. If it doesn't say 1, you're on the wrong page. So if you look up at the 4, that's what the page should look like at the top. All right. So like I said, and you probably saw some of this in 8th grade with geometric transformations, but you'll see it again in math too. All right. So with geometric transformations, today's all about the general, right? More of can you read the notation and figure out where you're going, okay? So you guys, up until now, have learned how to do it mostly graphically. So they tell you to do it in some way, and you just do it on the graph, all right? In this class, it's more about if I gave you a function representing a transformation, first off, can you identify what the transformation is, and then can you do it, all right? So it does deal with some functions in there. So just to recap, a function is a rule often given by an equation that converts or maps an input into a single output. And that's just a fancy way of saying no repeating x's. So if an x value repeats, it's not a function. Now, does anyone remember what an input is? In functions, what typically represents the input? The x value. So outputs are what? The y. All right, so how points work is that if you plug this x value into this function that this graph represents, the y value will come out of it. All right, that'll be the y value at that point. So, just a quick function review. If we're given the function f of x is equal to 2x plus 5, and they ask us to find f of 4, what am I doing? Plug the 4 in for x and evaluate it. So take a minute, do that very quickly. So that should be your setup. Go ahead and do your PIMDOS. All right, what you get? 13. So f of 4 is equal to 13. So if I rewrote that piece of information as a point, what would it look like? You have an x and y value technically. 413. It'd just be the point 413. Remember, another name for f of x is y. All right, so f of x also represents y. The only reason we say f of x is a lot of times, especially when we're naming functions, you want to list it as f of x, g of x, h of x, whatever, just so you can identify which function is which. Now, that's review from Math 1, 8th grade, whatever. So, the last exercise dealt with that function where you had to input a single number and the output was also a number. But now we're going to look at where the input is a coordinate point and the output is also a coordinate point. So this next exercise, this kind of involves how we read rules in transformations. So this next exercise, a function is defined by the rule f of the point xy, so that's what we start with, becomes x plus 5 and 2y. So this right here is what we call arrow notation. You will see this a lot in this unit. And all it is just one big evaluation problem. Because all it's saying is that if you start with the point x, y. You take those two values, you plug them in for x and y respectively in the next point. That's what your new point will be. So in other words, this is the pre-image, this will be your image. All right. So let's try this out. So letter A, 2, 7. All right, that's my xy. That's what I'm starting with. So what do you think I'm going to do to find the x plus 5, 2y? Plug it in for x and y respectively. So I'm going to plug in 2 plus 5, comma, 2 times 7, because that's our y. So these are two separate operations. We're not combining them because we're finding two different coordinate points. All right, so we're finding the x coordinate and the y coordinate. So what's my new point? 7, 14. 2 plus 5 is 7. 2 times 7 is 14. Not too bad, right? It's just a plug and chug. All right, let's try another one. Someone walk me through the setup for letter B. So it'd be -1 plus 5 and what? 2 times 0. So if I evaluate these two individually, what do I get as my new point? 4, 0. Try C and D on your own. Take about 2 minutes. Thumbs up if you're ready. All right. Check your answers. Does anyone need me to go over it? All right, moving on along. Now, sometimes in these functions, you can have the new x coordinate depend on the old y coordinate. So, exercise 3, very similar to what we just did, but slightly different. So, if we're given the rule h of xy, so that's our pre-image or our original point, and we want to turn it into y negative x. So, before we even start doing an example, let's just talk process here. What do you think I'm going to do? So, you got to make the x value negative, or flip the sign, or whatever. But then what also happens? You reverse the order. So in other words, the y value becomes your x value becomes your y value. Flip them. All right? Because the way to think about it is if you start here, how do you make this point look like this point? All right? That's how you want to think about it. All right? So we would have to make our x value negative of the original and flip the order. All right. So we'd flip it, make that negative. So let's walk through the steps for letter A. So what do you want to do first? What'd you guys say? Flip it? Is that what you said? Or we can make the 5 negative. So let's make the 5 negative first. Then what do? Flip it. So literally just switch the order. That's your answer. You could have also flipped it first and then made the 5 negative at the end. It doesn't matter. Everyone following so far? All right, what about letter B? What do I do? Flip it and make 7 negative. So this will be -2, -7. So what would C be? 0, +4. So remember, he made the -4 negative. That's the same thing as -4. Negative times negative is a positive. So that's why I like to say flip the sign, not make negative, just so that's essentially what that means. So this would be 0, +4. What about the last one? -5, -5. Good. So any questions on how to evaluate an arrow notation function? All right. So why are we doing this? Because it kind of involves the actual transformation. All right. So exercise 4. So they gave us this function. So if we start with xy, it becomes 2x, y minus 3. And they gave us these 3 points, which they already graphed for us. So take a minute. I want you to first find out the new points, which are labeled A prime, B prime, and C prime. So primes, or that little apostrophe next to the letter, that is what we in math dictate. We did one transformation. All right. So if you see a prime, that means one transformation occurred. We plugged it into one function. All right. So that's how you read it. You read this as C prime. If there's 2 little ticks, you call it C double prime. Math people are very simple folk. In the long run, when it comes to naming things, it's usually pretty obvious. So take a minute, plug and chug for all 3 of those points, and then go ahead and graph it. So find the new points and then graph your new picture. Those 3 points. sure you label those points as you graph them. Labeling is part of the game. Make sure they're labeled. Thumbs up if you're ready. Another minute. Alrighty. So someone raise their hand and tell me what they got for A prime. Yes. -4, -1. Good. So -2 times 2 is -4. 2 minus 3 is -1. Someone else, B prime. Yes. 2, 3. Good. So 1 times 2 is 2. 6 minus 3 is 3. And finally, C prime. Yes. So 4 times 2 is 8. 1 minus 3 is -2. So that's exactly what I got. If you graphed it, it should look something like that. Now, again, in this class, if you ever graph a figure, it better be labeled. All right, if it's not labeled, like if this is on a test, I would take points off. You need to label it. All right. So, transformations. A transformation is a geometric function that takes points in a plane as inputs and gives points in the plane as outputs. So if you don't know what a plane is, and I'm not talking about air travel, a plane is just the coordinate grid. All right, it's just a fancy way of saying the coordinate grid. So the input is known as your pre-image point, and your output is known as your image point. So in other words, the point that you're plugging in to the function, that's your pre-image. The point that you're getting out is the image. It's just like the same thing as your starting figure is your pre-image, your new figure is your image. So, first things first, we're going to map a transformed triangle of M and P using this function rule. So, first off, let's state the points of the pre-image. So, the points that are already graphed. What are they? So, what's M? -3, -2. So, that's the point for M. What about N? So, it's -3, +4, and finally P. 4, -2. Take a minute, find the new points, and graph them. So plug up those points into the rule and graph them. Thumbs up if you're ready. Give me one more minute. All right. Check your answers. So for M prime, I got the 0.22, N prime 2.8, P prime 9.2, and it's graphed as follows. Any questions on finding those points and graphing it? Now, here's my question. Is triangle M prime, N prime, P prime congruent to triangle M and P? Yes or no? Yes. Why is it congruent? What does congruent shapes typically mean? What does it feel? They're the same what? Same size and same shape. All right, so the angles make the shape. Okay, so congruent means same size, same shape. All right, so yes, they are congruent because again, they're the same size and shape. Doesn't necessarily matter the orientation, as long as they're the same size and the same shape, they're considered congruent. Now, why is this important? Well, there's a special name for geometric transformations that preserve the shape and the size, and that's called a rigid motion. So a rigid motion is a geometric transformation that preserves the shape, which is from the angles, and the size, which is the distances or the side lengths of figures on a plane. All right. So in other words, if the figure got smaller or bigger or it's stretched or condensed, it's not congruent. All right. But if all it did was maybe move upwards or get turned on its side or get flipped over, that's just a rigid motion. You did nothing to change the shape of it. You did nothing to change the size of it. So you just changed the orientation. All right. So this last problem, they gave us 3 triangle vertices, so E, F, and G. They also gave us 2 arrow notations. So they gave us F and they gave us G. So 2 different arrow notations. So here's my question. All right. Let's go to letter A first. So we're going to use F to map EFG to be E prime, F prime, and G prime. So we're using the blue function. All right. So what happens in the blue function? Flip the X and Y and X becomes negative. So E prime is now what? If I look at E, so I start with 2, 1, what's my new point? What, -2. F prime would be what? 3, -8. And G prime would be what? 6, -8. Good. Take a minute, graph that on your coordinate plane. All right, so when you graph your new triangle, it should look like the one in green. Any questions so far? All right. Now, they then want us to take the same points that we started with, so E, F, and G, and plug it into G, so that's the yellow function, to make M double prime, N double prime, and P double prime. So M double prime, N double prime, P double prime. Now, look up at the top. What's going on with X is negative and it gets divided by 2. And then what happens to the Y? Add 3. So let's just do it together. So for E, what happens with the X value? So it turns negative, so I have negative 2, and then I do what? Divide by 2, so I get what? Negative 1. Then if I add 3 to 1, what do I get? 4. So for N, I change F to be negative 8 divided by 2, so I get what? Negative 4. If I add 3 to 3, what do I get? 6. P double prime, I'm going with G. Should be the same X value as N double prime because it was the same starting value. If I add 3 to 6, what do I get? 9. Take a minute to graph that on your graph. So, here's my next question. Of the two images that we just graphed, which one's a rigid motion? Meaning it maintained the same shape and same size. So, was it the green one or the pink one? It's the green one. Why is it not the pink one? It got smaller. All right. So the shape maintained the same, just not the size. All right. So the one with the rigid motion is triangle E prime, F prime, and G prime. Now, just for funsies, what part of this yellow function do you think made it smaller? What part of this function made our triangle smaller? We divided the x by 2. All right. If I multiplied by a number, what would happen to the shape? They get bigger. So what happened here was a dilation. We'll get to that way later in the unit. But just know that if you multiply or divide by anything, more likely than not, your shape's not going to be the same. Not the shape, the size. Any questions on this lesson? All right, so your homework for tonight is pages 3 and 4 of your packets. Make sure you show all work to get credit. I will check it first thing tomorrow. All right. Also, on your syllabus, I forgot to mention this before we started the notes. That second page of the syllabus, make sure you sign off on it and get your parent to sign off on it and turn it in by next week. It'll be a free classwork grade. So free 100 on a classwork grade. So that's the other part of your homework. Yes. Also, keep up with your patty paper. I highly recommend holding on to it. You will still be using it. If you think you're going to lose it, feel free to write your name on it and put it in the turn-in box. You can grab it tomorrow.